Hello everyone, how are you?
Good.
Excited to be in Astrodynamics? No. Good, good. Alright, so welcome back. This is Astrodynamics, EAS 4510. My name is Riccardo Bevilacqua, of course I'm the professor for this class. And today I'll just break the ice, I'll introduce myself. We'll go through the syllabus in details because that is the thing I do at the beginning of every semester. I think it's important that you guys know there is a syllabus and you're well aware of the contract for the semester, as I call it here. So as you can see here, we're filming the lectures. Patrick Kelly is your TA, and I have done this experiment last year for Astrodynamics as well. And I think it was a pretty good experiment. I enjoyed it. I think the students enjoyed the availability of video lectures online, which, by the way, are all on YouTube. So last year's offering of Astrodynamics is completely open to you to watch those videos if you want. Everything is there. At some point, I thought I would probably remove them, but I don't think it makes any sense. Everything is posted. You can reuse it. I will change a few things along the way. I don't know yet, but definitely you have a lot of resources. So we'll try to do this. There is no promises that we can keep it up. I said the same last time, and we did, but it's a lot of work. I think it's very beneficial. We'll talk about it a little more in details, but I'm not going to promise that we'll have every single lecture recorded. I want to do it because it's very useful, but we'll try. Once we're done with these, I have to convert all these videos, reduce the size, merge them together. This camcorder is pretty old, so it's a lot of work, but we'll try to do it. But so today, really, lecturing-wise, it's going to be minimal if we can, but I want to go through this. So this is myself. My office is right there, 308. It's the room almost in front of this classroom here. Phone number is there. Office hours are Mondays and Wednesdays, so today I have my first office hours right after class. We finish at 3:50. Just give me 10 minutes to wash my hands and relax a little bit, and then we can talk about your issues if you need to. And I use Canvas. You all see the class on Canvas, of course. I think I put it up a few weeks ago, so it should be available. And I also use my website. So if you want to find everything in one place, which is really open to the public, you just go here, and I have all the previous offerings of other classes, and this in particular is Astrodynamics from last semester. There's all the lectures, all the exams, all the homeworks, all the solutions, all the MATLAB files, everything is there. As I said, at some point I wanted to remove everything, but there's no point. I think you should have as much material as possible available so that you can work through the problems and exercise. So everything is there. I'll try to post basically the same things you see on Canvas here as well. Because I do believe in open source. At the end of the day, people may be interested. I have random people watching these videos. They don't get credits, of course, but they enjoy them sometimes. Or they complain, in which case I just ignore them. I will not ignore your complaints. That's a different story. But so that's the material. We meet. You're here. The number of people in this class will go down, especially because I told you that I'm going to record the lectures. But if you can't keep up with the lectures independently, that's okay. I don't enforce attendance, but don't rely on the previous year's videos because I may change a few topics. I definitely change the homeworks, the exams, and I will introduce them in class. So you really want to be on top of this semester's offering of the class, okay? And don't come to me, and this is experience, I'm not just making this up. Don't come to me the day before a test telling me I am 10 video lectures or more behind. What can I do to do well in the test tomorrow? What am I supposed to say? Just pray. That was the only answer I could come up with, but I didn't respond. So I've had people doing that, so don't do it, please. Be on top of the classes, because this is a dynamics-based class, and will be slow at the beginning, but then we'll start picking up. And the homeworks are MATLAB intensive. You really need to be on top of what we're doing. Your wonderful teaching assistant is Patrick Kelly, who I have introduced already, who's doing the cameraman as well. And sometimes he may not be available to do this, so if one of you will volunteer in one of those occasions to film, that would be much appreciated. Patrick is working on his PhD, and is working on astrodynamics as well. He's working on solar sailing and creating constellations of satellites around Mars. We want to create GPS-like constellations around Mars using solar sailing. So you have people in this group, in this small group, myself and Patrick, and we'll probably have a grader that have a lot of experience with astrodynamics. You should be in good hands. You also have office hours, which do not overlap with mine, of course. On Tuesdays, 1 to 4, is that what you wanted? Okay. And the lab in which we work, called the ADAMUS lab, the Advanced Autonomous Multiple Spacecraft Lab, is just downstairs here, is room 211. And that's where he will have his office hours. Before I move on this, I want to give you a little bit of my background, where I'm coming from, what are my qualifications, so that you hopefully believe I am the right person to teach this class. I'm originally from Rome, Italy. I was born in Rome, and I got my master's in aerospace engineering in 2012. I'm sorry, 2002. Yeah, I wish. I just cut 10 years off. So when I did that, it was a different setup, where you would go through 29 exams all the way to a master's degree with a required thesis at the end. So it was a pretty long and involving process to get the equivalent, I guess, of a master's degree in the US. I went to Spain for about a year. I worked at Gruppo Meccanica del Vuelo, which is the group of flight mechanics, where they mostly do mission analysis and software for satellites, and it was a lot of fun. But I wasn't done studying, so I went back to Rome, started my PhD in applied math, but I really kept working on aerospace engineering type of problems, and spacecraft and orbital mechanics. And that's when I started coming and going. I started bouncing back and forth between the US and Italy. In particular, I was a visiting PhD student at NPS, the Naval Postgraduate School, where I spent almost a year of my PhD there. And then I was offered a postdoc, and I basically moved to the States. 3 years of postdoc, doing basically only research. And I started as a faculty at RPI, Rensselaer Polytechnic Institute, which is upstate New York. For 4 years, I really wanted to be close to Kennedy. I really wanted to be a UF. It didn't work in 2010. It worked out in 2014. And so over 2 years ago now, I moved to UF, and here I am. Also, a few other things that I've done over the years. I spent a couple of summers working with the Air Force in New Mexico, with the Space Vehicle Directorate, and Patrick spent one of those summers with me. That's how we started working together on solar radiation pressure and controlling satellites with solar sails. And so that's the fun I've had in the last more than 10 years. It's a very fun job, I think. I enjoy astrodynamics. Everything that we do is based on astrodynamics. So my lab, just to give you an idea of what we do, focuses on guidance, navigation, and control of formation flying of satellites. So we care about spacecraft that are kind of close to each other, and that close can be meters, hundreds of meters, a few kilometers. It really depends on the application. But we try to develop theory that optimizes maneuvers so the satellites can rendezvous or maybe fly around each other and monitor each other or remain in a tight formation. There's several reasons why you want to have these kind of missions. So we do theory. We do try to come up with alternative ways to control satellites. Patrick's work, its intention is to control satellites without any thrusters, using solar sails instead. We've done that with drag forces. So we do a lot of theory that has to do with orbital mechanics, of course. But we also have so if you ever go see Patrick at his office hours, we have a flat epoxy floor where we operate what we call spacecraft simulators, robots that use air bearing technology and try to reproduce the motion of spacecraft when they're close to each other. So we have the second level of research, which is hardware in the loop. And we have a couple at this point, CubeSat projects ongoing, if you are familiar with the concept of CubeSats. A CubeSat is 1U is a 10 by 10 by 10 centimeter spacecraft. It's a box, tiny box. You can have up to 6 or 12, I think at this point, U CubeSats. Still boxes that you can hold in your hands. And universities, and not only at this point, are pretty aggressive in designing CubeSats and flying experiments in low Earth orbits to see if your new thruster is working, if your camera is working, is whatever project, usually student-led project, is actually a piece of hardware that can perform a mission. So that's the type of stuff that we do. This is my background. Going back to this, so hopefully you believe that we'll be able to teach you something about astrodynamics here. We are all very excited to do this stuff in the lab. We all like it very much. But, you know, it doesn't matter how much I love it. I have to be the professor in this particular setting, so I have to set some rules. First set of rules is that there are prerequisites. I'm not going to waive these ones. So if you don't have any of these, you should really come talk to me. It doesn't matter if someone allowed you to register. I have the last word on prerequisites, and I'm pretty serious about prerequisites, especially both of them really here, but especially dynamics. I'm going to start writing stuff at the board just so that we understand each other. This class is called Astrodynamics, okay? And it's not just called Astro. It's called Astrodynamics. If you do not have dynamics, there's no point for you being here. We use the transport theorem, we use kinematics, we use kinetics, we use that stuff all the time. And I cannot teach it all over again. I'll refresh it in the first few lectures, so it goes slow at the beginning, but that has to be on your CV. It would be a disservice to you to teach you an astrodynamics class without that background. It would just be painful. Why would you do that? Okay, so those are the prerequisites. Now, when I say strongly preferred MATLAB, I basically mean that we use MATLAB. And I believe you have taken a class on MATLAB in the past. So we'll mostly use numerical integrators like ODE45. Not everything that we do has an analytical solution. And then we'll visualize the orbits. We'll have some numerical solutions. I'll have to come up with the homework. So I don't know exactly what I'll give you. But just to give you an idea, last year, one of the things that we have done as an homework was the students were able to track to create the ground track of the International Space Station, everything in MATLAB, and spot when, in a certain time frame, it was going to be very close to Gainesville and visible. And it would match what you find on your application on your iPhone or online. So that's the kind of stuff that I want you guys to be able to do by just coding it from scratch yourself. Because you're going to be living here with astrodynamics in your pocket, and if you're not able to do that kind of work, then we're just wasting our time. So we're going to use MATLAB quite a bit, because I want you to be able to solve the problems yourself. And the objectives are really what you see there. By the end of this class, I hope that you will definitely understand the different types of orbits that can arise under the laws of gravitational motion. Now we start with a simple force model where we assume that the planet is a sphere and the mass is uniformly distributed in that sphere. Now if you go online and look for the GRACE mission, for example, and you try to visualize what is our current knowledge as human beings of the shape of the planet, it is a very weird potato with a lot of bumps. It is not a sphere. It's very strange. So we'll start with that model because it's very nice and it allows us to talk about orbits that don't change with time, but then there are actually what we call perturbations on top of that model. We can model the different shapes of this planet. We'll have the drag force in low Earth orbits. We'll have solar radiation pressure if you go above low Earth orbit. If you want, the moon and the sun also have an effect on your spacecraft. So there's other things that actually happen. And perturbations, as far as I can tell, are not something that you would see in a senior astrodynamics class. You usually see it in a graduate astrodynamics class. But for me, teaching you astrodynamics without perturbations is absolutely pointless because the orbits of spacecraft do not remain frozen in time. They do change. If you want to track the International Space Station and you don't include what is called the J2 effect, the fact that the planet has oblateness at the poles, you're going to obtain a trajectory that makes absolutely no sense. And why would I give you that? That would be another disservice. So I'll do the perturbations. We'll deal with those. Maneuvers, of course. We are engineers. We want to control these objects. Maybe we need to go from an orbit to another. The space shuttle used to go to the International Space Station through insertion in a lower circular orbit and then a couple of maneuvers to get to the actual rendezvous condition. So we do maneuvers all the time. And that's the same for the ATV or HTV, all those cargo resupply vehicles that go to the ISS. They go through some maneuvers before they dock. Then, let's see, this is very important. As I said, we do care about formation flying and proximity operations in my lab. So that is one reason why I want to talk about proximity operations, how you model two spacecraft that fly close to each other, what kind of equations of motion we can write, and how we can control them. So I don't do it just because it's our research. It's because what we have done since the dawn of the space age. Rendezvous and docking, it's all over the place. They've done it manually. They are doing it semi-autonomously these days with the resupply vehicles. But the ISS was assembled by having pieces coming together in space, and we're going there with astronauts, and not only. So it is absolutely important. NASA is planning its Martian missions as a two-phase type of mission, where you would have, I believe, supplies going first, and then people going after, and then the two spacecraft would eventually meet and connect to each other. So this is very important theory to know. And towards the end, we'll very high level scratch the surface of preliminary design of interplanetary missions, how you go from planet Earth, from an orbit around this planet to an orbit around Mars, for example. And there's really nothing tremendously new about this last topic here. We'll basically use what we learned at the beginning of this class. We'll just use it, including more objects in the picture. Instead of having just a satellite around Earth, we'll have a satellite that leaves Earth and then goes around the Sun and then goes around Mars. But we'll patch all those trajectories together. Okay, so stop me anytime if you have any questions, by the way. ABET. I really don't want to read this to you. You're more than welcome to read it, but I have to have it in the syllabus. This is an accredited program. UFMAE's program is ABET accredited, so this is a list of how this class is meeting some of those requirements, and so you can read it yourself. But this is more important to me. I will try to stick to this timeline here. It doesn't mean that there will be no modifications. It really also depend on how you guys are doing in class. Did you break it? No. Okay, good. Okay, so we're here in the first 1 or 2 weeks. I really want to refresh Newtonian Mechanics so that we're all on the same page. And some of you have taken dynamics, last year or maybe the year before. Have you all taken it with Dr. Rao, possibly? I follow his book when I teach dynamics. Many of us in this department follow that book. It's a great book. I like it. I really want to refresh some of the things that we'll use. And then we'll start with a two-body problem, or Keplerian motion, where the planet is a sphere, uniform mass distribution. And from that simple model of force, we'll come up with trajectories that are conics. We have circular orbits, elliptical orbits, parabolic and hyperbolic orbits, depending on how the satellite is injected into orbit. Position and velocity will change that shape. And we'll talk about what the integrals of motion are, Kepler's laws. So everything is ideal here. There's no perturbations. Everything is perfect. After that, we'll connect. This should be an R bold, meaning a vector. At least that's the intention. We'll connect the position of a satellite with time. There is no numerical analytical solution for that, so we'll talk about the Kepler's equation that allows you to tell where a satellite is at a certain time. But there are other ways to represent the position of a spacecraft around the planet that are much more user-friendly than x, y, z, and x dot, y dot, z dot. I'm sure you've heard about semi-major axis of an orbit, eccentricity of an orbit, inclination of an orbit, right ascension of the ascending node. These terms go around sometimes, especially if you are an engineer, especially if you're interested in space. But these, what are called orbital elements, are very useful to visualize in 3D basically the size, the shape, and the orientation in space of what we call the orbit. Where everything is ideal, this orbit will not change. You just have a track in space that you lock in place, and this point mass, which is your satellite, just goes around, 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 around. which is not true, because there are perturbations, but we need to model that and then build on that simple model to refine it. Maneuvers. Impulsive maneuvers are great because you can solve them analytically. You don't have to do anything other than change the velocity at a particular position instantaneously, and magically you are in a different orbit, which is almost true. But then we'll also talk about non-impulsive maneuvers, and MATLAB will come back there because you have to integrate the equations of motion numerically. And this is the part I really care about. Orbital perturbations. Everything we do here is ideal, but reality is a lot more complicated. So we'll start talking about Gauss variational equations that tell you how these orbits actually don't remain fixed in space. They may enlarge, retract, change eccentricity, change a little bit orientation. Maybe that orientation oscillates with time. There's a lot of things that happen to those orbits because we are not living in an ideal universe. And then we'll start talking about relative motion, rendezvous, etc. This is the last part, interplanetary trajectories. And I have that extra week of advanced topics just as a buffer. I don't know what we'll do. Depends on time. This is a lot of stuff. So I've seen other classes on astrodynamics in other universities. Quite frankly, they don't do this. They don't do this. I think this stuff is extremely important. I really want you guys to be able to program in MATLAB your own software that tracks the position of a satellite and has a realistic model for where the satellite is going to be. I was amazed last year. People were just able to tell me the ISS would be the closest to Gainesville at this particular date and time, and it would match the prediction that you can get online. And people did it by themselves. So that's the kind of level that I'm targeting here. Okay, so textbook. I think, if I'm not mistaken, I said that this book is required, right? Now, the third edition of this book, which is the one I have, is the one that I put on the system. I enter in the system as required. I have an electronic version of my. I bought it, of course. I have an electronic version of my laptop. If space, astrodynamics, if this kind of topics you believe are in your future, I recommend you buy this book. Just make the investment. I think it's less than $200. I don't remember exactly what it was. More than 100 for sure, to get the electronic version. But if you don't want to do that, I believe the library has the second edition online, so you can get it for free. You just have to go online every time. But it doesn't have, if I remember correctly, it doesn't have the orbital perturbations chapter. But I do have a PDF that is non-printable and has some constraints, that I can give you. That's what I've done last year. So it's really up to you. If you don't want to buy it, just let me know and I'll share. I'll probably just post that PDF, the perturbations chapter, on Canvas. But again, if you think that this is in your future, that is a very good book. So, and MATLAB is strongly preferred, which means we use MATLAB. All right, so this is the part that you care the most about, probably. All right, so you're seniors, which means I shouldn't even give you homeworks. You should be on top of your stuff at this point, but we'll still give you homeworks. 3 of them. You take them home. You have 24 hours, which means probably 30 or more, because I'll probably post them the day before in the morning, and you have until midnight of the day after. Plenty of time. They don't require 24 hours. They require 2, 3, 4 hours maybe. If you have studied and you are on track with the topics, I just give you an entire day. So you can work with that day. The idea is that these homeworks that are 5% of your grade, I'll give them exactly a week. All this stuff is on Canvas. The schedule is there. And those are the dates. Actually, sorry, for the homeworks, the dates were in this schedule here, I think. Yeah. Homework 1, February 1st. Homework 2, March 15. And the third is April 12th. So it's exactly a week before we do a test in class. So the idea is that you get ready for the test doing the homework. You just practice with the homework. And you get 5%. Now, that doesn't mean that you cannot open the book and solve more problems. You can do that. I'll give you also uncollected homeworks here and there, just suggestions for things you can do. I encourage you to do them. Last year, I gave a lot of uncollected homeworks that basically were the homework, And those who paid attention, just cruised through the homework. They didn't have to think about it. And those who ignored, those suffered. That's it. So just be on top of what we do, and it should be fine. Now, and so 3 homeworks, 3 tests. I hate finals. Do you like finals? Okay, good. We agree. I don't have finals usually. What I'll do, I'll just take 3 days of regular class and give you 3 tests that, of course, can be done in 50 minutes. Yes?
Sorry.
No, go ahead.
I was wondering about open book notes for tests.
Oh, yeah. Yes. There are open book, open notes, open MATLAB if you really need to, but I try, in 50 minutes, I definitely try not to give you something where you need to numerically solve a crazy equation in MATLAB. They're usually very quick questions that you should be able to solve without computer. But you can use a book. I come up with the questions. I don't pick them from the book usually. So you can use your notes, and yep, everything is open. So February 8th, what is it? March 22nd, and this is basically the last day of class, April 19th. And the reason why the weight increases is simply because I want to give you a little more, I want to be a little more relaxed with the first one. Yeah, first astrodynamics test, you're afraid, you're scared, you don't know what to expect. You should know what to expect, but then from the second on, you should really know what it is that we're doing. So 20%, 30%, 35%. Now, I'm going to say this once and for all. If you don't get an A in this class, it's because you don't want to get an A in this class. And it's not because it's easy. It's not going to be easy. It's because if 100 points is A, I am giving you 25 points of extra credit that you can accumulate. Okay, so you can get an A from just having 75. If you do these things that you don't have to do, but I just give them to you because I think they're very valuable. First of all, I do this for all classes. Midterm survey, which is 5 points. I care about your feedback. You guys care about your grade. I get a grade at the end of every semester. I care about that too. But you have 3 homeworks, 3 tests. I have 0. I have 0 feedback unless I do this in the middle of the semester, until the end. And since I care about how the class is going, I always do this, maybe sometimes in February. I'll give you a few questions, you just respond to them, send them to the TA. I don't need to see your individual questions and responses. It's anonymous. It will just do a final statistics of how many have responded between 1, 2, 3, 4, 5, the usual scale. And I'll discuss that with you in class. And so as an incentive, I'm giving you 5% bonus so that everybody does it. You wouldn't believe how many people don't do it. It takes a minute. And 10% or so of people just don't do it. You lose 5 points. Because if you don't return it to me by the deadline, you're not going to get the 5 points. So just do it. It's useful for me, and it's extra points. It's free 5 points. And this is very important. Now, this is not required. I'm going to start from the bottom here. This is not required. You don't have to do this. But STK Systems Toolkit, it's a piece of software that is used by Lockheed Martin, Boeing. Anyone who's a satellite owner and or operator uses this kind of software, that it's very powerful to visualize orbits, to analyze so many things, mission analysis. You can analyze if 2 satellites have line of sight of each other for how long and during which time frames, or do that between a satellite and a ground station, or multiple objects. You can have airplanes in these environments. You can simulate so many things. It's very powerful, using in research. And how many will be in Aerospace Design 1? Probably, next semester. I thought that, and what we'll do next semester probably, again, is we'll design an entire satellite where the mission analysis piece will be done in STK. The maneuvers you have to perform, whatever the satellite has to do, orbits-wise, will be done in STK. I do give the same kind of bonus points in that class. So you double dip if you are in that class. Now, you can get certifications for these. First of all, I can give you licenses that are educational licenses, because I have an agreement. They have educational agreements with universities. And you can get certified in the use of STK, which means you go through tutorials online with what they provide, and you do a test with them. I have nothing to do with the testing with STK, okay? I don't grade STK testing. It's all between you and AGI, which is the company developing this. You can get 2 levels of certification. It used to be just one big certification, that's what I have. But now it's first level certification. If you do that, you get 10 points. If you also do the second level, which is called master's level, you get another 10 points, which is 20. You put this certification in your CV. You do it for free. People who do it after college have to pay. I think it's $600 a cost. We use it next semester. It's just an additional line in your CV. It's used. I'm not just making this up. It's used by a lot of private companies, and not only. Now, again, this is absolutely not enforced and not required, and it's up to you. And this is your response to the question that someone will ask me, what can I do for extra credit? 25 points, right there. Okay? And it's you know, it's very useful for you to do it. Believe me, the first level certification, you can have it by next week. Download the software, go through the exercise. It's just one exercise, and you have your 10 points. I really want to incentivize this. I'm not going to enforce you, okay, to do this. I'm going to force you to do this, but it's absolutely useful. I will use STK at some point, but not now. For now, we haven't talked about orbits, we haven't talked about maneuvers, I can open it, I can show you some things, but it's pointless for me to teach STK. And again, this should be your independent project. It's really all on you. That's my idea. This is the deadline. Last day of class, last exam is when you have to turn in the proof, which is an email you get from them that you're certified. And again, it is on you, meaning if you turn in the material to get STK certified on April 18th, and then you tell me, I don't know how much time it's going to take them to grade it and return to me, I do not care. Time it wisely. Don't wait until the last minute. Because if you turn it in on April 18th and they don't respond to you until April 28th, that is the deadline. Because it really should not take you this much time, you know, waiting until the last minute to do it. They're usually okay. If you run in a rush, they will do it in a day. I can send them an email. They will respond quickly. They're not monsters, but you know, if you wait until April 19th to turn it in, then it's probably an issue. So let me open a few things here before we move on. This is on their website. Not working. Why not? Oh, it's here. So this is what I talked about. This is the first level. It really takes no time. It's very quick. And this is the second one. It's a lot more involved, and you have to do a lot more problems you have to solve and turn in some files to them. You also get $20 Amazon gift card if you refer your friend.
For students?
I don't want to know how you guys do this. I mean, you can do it. I mean, start seeing people driving in Ferraris here. I don't want to know. You know, I don't get anything from AGI for advertising this. Just to be clear, I just use this stuff. I use it for research in the lab, and we use it for Aerospace Design 1. And people use it. I know students who left my group who use it at Lockheed Martin and not only. So it has a meaning to be there. Now, how do you install this? I don't want you to waste time. I don't want you to waste any time and wait until the last minute. So if you go, this is also on Canvas, go on my website, on this PDF, getting STK educational license, okay, you do what I'm saying here. You create your account here, create an AGI account with your email. Then once you have an account, where is it? Go back. You go to this other page, go at the bottom of the page, as I say, download this, it's free. It's the current version, 11.1. Then on the same page, let me copy this code. There is a get edu licenses at the bottom, right here. I need to log in. Please remember my password. I hope. Yes. Okay. This is all in that PDF. You go on-demand licenses, continue, enter your code, continue. There is a class called, here it is, Astrodynamics, leave everything else as it is, agree, generate license. It will create the license file in a second. You can save it, or you can just ignore it. You will also get an email because you've created an account with your email. You should get an email from them with the license file and the instructions. Here it is, something like this. Okay? So do this today. Don't waste your time. Install STK. It's there for you. So you don't have to rush at the end of the class. Let me finish with these, and then I'll open STK, show you a couple things. Grading policy, it's nothing really to discuss. E is less than 45. You really have done absolutely nothing if you have 45. And then it's all linear all the way to A. There's no secrets. All right, so this is a big class. I expect you to come to class. I don't take attendance. I don't care. But again, if you, before a test, are 10 lectures behind, there's nothing we can do. As a rule of thumb, there will be no early or late exams. The dates for the homeworks and exams have been up for almost a month at this point. No makeup exams, rescheduling, all that stuff. If you have an emergency, you come talk to me, we'll figure it out. Try not to have emergencies, because they're usually bad things. I hope you don't have any emergencies, but the dates are set. And there's also rules in the university's website about makeups, etc. Students with disabilities. Now, for the homeworks, as I said, they don't take 24 hours, so there's really no accommodation there that I see as a need, even if there is a requirement for more time. But for the tests, yes. Some people may need double the time. The DRC decides who is entitled to have more time and will make arrangements, of course, but you need to tell me now, not after the first test and after you get a poor grade on the first test and all of a sudden you try to convince me and DRC that you need more time. I've seen that. I'm not making this up. I've seen that. That becomes very nasty, okay? Because these people are not there to waste their time, but they have to do this stuff at the beginning of the semester. Otherwise, you put everybody in a very uncomfortable situation. So if you need more time, just come to me with the documentation, we'll do it, and it's perfectly fine. It's part of my job. There is a lot of words here. I'm going to stop at the first three. Absolutely zero tolerance. If you cheat, you fail this class. There is no crying that is going to save you. If you cheat, we're not friends anymore. We're friends right now. If you cheat, we're done. Patrick and I have enough experience to tell who's copying the code from someone else. So the homeworks are take home. Of course, we're not home with you. But it would be very stupid not to do it by yourself, because then at the test, for which the homework has prepared you, you will be by yourself. So take those 24 plus hours to actually understand the topic and do some work. But there is no tolerance. I don't want to hear it. Once we determine you've cheated, we're done. But I'm sure it's not going to happen. It didn't happen last semester. So you guys are seniors. You've passed this stuff. And students' evaluations, I do care about them a lot because they give me feedback, and we change classes according to the feedback if needed. Now, one thing that I have to say about filming in particular. I asked the department chair authorization to film classes and post them online, and I can do it as long as you guys are not in the video. So I need to ask you one thing. Don't come late, first of all. But if you really have to come late, there is another door there. Because if you start walking in front of the camera, it may be an issue. I can't have recognizable students, in the videos. Sorry. And in general, you may be disrupting the lecture if you keep coming late. If the same person keeps coming 10 minutes late, it's a problem. I usually don't eat while I speak. I cannot do that. So hopefully you won't do that as well in class. So I think that's all about the syllabus. I hope it's clear. I hope there's no confusion about what to expect. Any questions? Yes?
For that certification exam,
yeah.
Can you take it whenever you want?
Yeah. Once you're ready, so you basically go for both levels, you go through a bunch of tutorials, exercises by yourself. Once you feel you're ready, so don't do that until you're ready. You say, okay, I'm ready for the test, I want to take the test. And then you click somewhere that you want to take the test, and I believe they give you a certain number of days to do it. So the moment you click, you're certifying I'm ready, and I'm going to work in the next week, 1 day of that week to turn in the files that you need. But yeah, they give you plenty of time. And if you don't pass the first time, you can do it again. They're really nice. They're not. They want, of course, they want people to use their software. So it's really not that crazy difficult, and it's very enjoyable. Let me open. Ask more questions if you want. Let me open STK. No more questions? Nothing? Anyone has interned anywhere doing space? Yeah.
Orbiter?
I'm sorry?
Orbiter spaceflight simulator?
If I ever used it?
Have you used it?
No. No. Have you used it?
It's really interesting.
Is it?
A lot of the stuff you're talking about.
Yeah. So it's probably similar to this, where you visualize the planet and you can visualize the ground track. Does it have 3D views and 2D views? I know there's alternatives to this. For example, one of our sponsors at Kennedy Space Center, one of their contractors has a different software. Well, it looks very similar. It's called Free Flyer. It does pretty much the same things. The difference is they don't have any educational agreements. I can't get educational licenses. You can't get a certification. There's no fun behind using that software. So this one is a lot more. They have a very good, university department. They care about students using this. So you open SDK, you create a scenario, you create your virtual world, right? Example, just to give you an idea of what kind of stuff. So this is the kind of stuff that SDK can do, and you guys will be able to do in MATLAB. So I want you to get to a point where you can do the stuff that commercial software does by coding yourself. It's not a coding class, but you need to have the tools. You will have the tools to do this. Okay, example for Astro. Playing with STK. Can you see okay? Should be able to see, right? And we start today, we go, I don't know, we go until the end of the month or something like that. And so this is creating an empty scenario where there's no objects, just the planet right there. It's a pretty nice planet. Okay. So I'm going to start inserting things such as Gainesville. How about that? I'll search for Gainesville here, Florida, and we have our home right there. Okay? And then I'm going to insert a satellite, hopefully the ISS. Okay? ISS. Now there is one whose ID is 2554 something. Can you see it? You see it? Actually, I think I can search for that ID. Hold on. 25544. Is that the right one? Yes. Okay. So this is the actual NORAD ID of the International Space Station. I think the second one is the right one to use, but doesn't matter. This is just to show you. So now we have ISS right there. All right. I don't know how I can reduce the size. Oh, here it is. And you can animate this. Satellite is going around. You can make it go faster or slower. But this is just visualization, right? It's not a big deal. And the same is happening in the 2D view. So what the guys did last year for Astrodynamics in one of the homeworks was basically this. The ground track. Now I don't have the option to save the old ones. As you can see, it's erasing the old ground track and it keeps going. But last semester we created a ground track for 1 or 2 days. Gainesville was there and they were able to match what STK was telling them. But one of the things you could do, for example, is I want to see when there is line of sight between Gainesville and the ISS. It doesn't mean that you can see it because there's other things involved, distance and elevation, etc. But at least they can maybe communicate, right? So Gainesville to ISS. And then once I have this access, it's called an access report, I can look at this, for example. So this is telling me that between January 4th and the end of the month, the time frame that I've chosen, every time I think you have a red spike there is line of sight. They can see each other. So this is the kind of stuff that you can do with STK. This is a very simplistic example, just to give you a quick introduction to STK. Does it look cool? I think it's very cool. Okay, so any questions? We have a few more minutes, and I'm going to start talking about this class a little more in details if you want. No? All right, so astrodynamics. The dynamics part is what we're going to care about to begin with. But let me give you one thing to start. Instructions for use of this class. Now it's silly probably that I'm telling you this because you're seniors, but you know, doesn't hurt. Okay, this is the sequence you need to keep in mind. There is a syllabus. I'm going to stick to the syllabus, and you should as well. You need to be aware of the syllabus. There is a book. I am the filter between you and the book. I pick some topics. I compress things. I explain concepts similarly to what you see in the book. In some cases, I don't. For example, that book reviews dynamics at the beginning. I think it does a terrible job. I don't really like that part, but the rest is great. So I'll just do dynamics my own way. But there is a textbook. No one is stopping you from opening the textbook, solving more problems, studying more stuff, expanding if you're interested, okay? But then there are the lectures, which is what you need to pass this class. Do not fall behind. That is the only advice I can give you. Do not fall behind. Problems, homeworks, of course, you need to do all these things before you come to office hours. Now, if you are doing great and you don't need to see me or Patrick, that's fine. But between myself and Patrick, there's 6 hours of office hours every week. After you studied something and you really determine that you're struggling with that concept, after you've done that and you're prepared with some questions, you come to office hours and we'll be happy to talk to you. Simple, no? But you wouldn't believe how many people don't know that there is a syllabus. And they ask me, when is the test? I'm not going to respond to that. It's on the syllabus. What is the textbook? I've heard that. So just to be clear. So these are the instructions for use. Now, let's get serious about refreshing dynamics, because this part is coming in a few days. But dynamics is first. What is dynamics? I need to refresh dynamics. It's going to be boring. Motion, yeah? So what we do in dynamics, we do 3 things. I believe I can say that we do 3 things. The first thing is representing motion. We represent, we explain motion. And guess what? The ground track exercise, all that stuff that you do with satellites to tell where they're going to be in 2 days, that's predicting motion. When you integrate numerically the equations of motion, you're predicting the future, right? That's what you're doing. So in dynamics, we represent motion of a particle, of a rigid body with flexible appendages. We're not going to do any flexible things here, but so for us it will be particle and rigid bodies mostly. But we do represent that with Cartesian coordinates, angles, Cartesian coordinates and angles, cylindrical coordinates, whatever you pick, to represent where that point is in space and how it's moving. Then we have the laws of mechanics to explain why what is happening is happening. And then when we combine the representation and the explanation, we are enabled to predict what's going to happen, which is equations of motion that we can solve. So from next time, we're going to refresh what is kinematics, what is kinetics, the main tools that we're going to use in this class, okay? And I think the time is up.